In this video lecture session, we aim to cover the following topics: names, locations, addresses, reset values, and functions of all special function registers, SFRs. Gain an understanding of the various special function registers, their addresses, default reset values, and their respective functions. Details of key registers, explore the specifics of the PSW, accumulator, B register, and stack pointer registers. Learn the procedure for selecting different register banks. Identify and understand the bit addresses of different special function registers. Let us revisit the memory architecture of memory of MCS 51. The range 00H to 1FH is reserved as register banks. The MCS 51 microcontroller architecture typically offers 4 register banks designated as Bank 0, Bank 1, Bank 2, and Bank 3. Each bank consists of 8 general-purpose registers, denoted as R0 to R7. These register banks provide a range of memory locations for storing data temporarily during program execution. The ability to switch between register banks allows programmers to efficiently manage data and optimize the usage of available registers for different tasks. The bit addressable area spans from memory address 20H to 2FH. Within the MCS 51 architecture, this area comprises 16 bytes of internal RAM, totaling 128 addressable bits, 16 times 8. Each bit within this range can be accessed via its corresponding bit addresses, ranging from 00H to 7FH, as depicted in the figure. Example, the status of a motor may be represented through a single bit. The bit addressable area helps to store Boolean variables, resulting in economical usage of the system memory. If not used for bit variable storage, the unused bytes can be used to store information in the form of bytes. Memory locations from address 30H to 7FH serve as storage for general-purpose data. Programmers commonly utilize these 80 locations to store temporary data and intermediate results. One advantage of this memory area is its faster access speed compared to off-chip RAM. Additionally, this memory segment often functions as a system stack. Now let us examine the special function registers in the Intel 8051. We'll also explore the advantages of the MCS 52 series over the MCS 51. In the MCS 51, a 128-byte area is reserved for SFRs. The dark-shaded rectangles represent imaginary memory locations and are not physically present. Out of the 128 locations, only 21 are used in the MCS 51 for special functions. Additionally, 6 more locations, from CAH to CDH, shaded in yellow, are designated for special function registers related to timer 2, which are available only in the XX52 series and above. Here we can observe the 21 major special function registers along with their direct addresses and reset values. The bit addressable options for relevant registers are also included. It is important to note that if the least significant nibble of a special function register address is either 0 or 8, then that SFR is bit addressable, otherwise, it is not. The program status word, PSW, is an 8-bit register, also known as the flag register or processor status word. A flag is a flip-flop, a 1-bit storage element, used to store and indicate the nature of the result produced by the execution of certain instructions. The state of these flags, either 0 or 1, is tested by other instructions, such as program flow control or branch instructions, to make decisions. As we can see, two bits of this register, specifically bit 3, RS0, and bit 4, RS1, are used to select one of the four register banks, bank 0, bank 1, bank 2, or bank 3. The carry flag is a fundamental concept in microcontroller operations, particularly in addition and subtraction processes. When an addition operation results in a carryout from the most significant bit, MSB, also known as the D7 bit, the carry flag is set to 1. Conversely, during subtraction, if there is a borrow into the D7 bit, the carry flag is similarly set to 1. In addition to its role in arithmetic operations, the carry flag also functions as the accumulator for Boolean operations, enhancing its versatility within the system. Importantly, the carry flag can be directly modified using bit-level instructions, providing greater control and flexibility in programming. Understanding the role and manipulation of the carry flag is crucial for efficient and accurate microcontroller programming. In the Intel 8051 microcontroller, the auxiliary carry flag, AC, is a special flag used primarily in BCD, binary coded decimal, arithmetic operations. The auxiliary carry flag is set if there is a carry out from the lower nibble, the least significant 4 bits, to the upper nibble, the most significant 4 bits, of an 8-bit addition or subtraction operation. F0, flag 0. It is a general-purpose flag. It can be used as a 1-bit memory location to record some event. RS0 and RS1, register bank select bits. These bits are used to select the register bank. If the combination is 00, then bank 0 is selected. If it is 01, then bank 1 is selected. If it is 10, then bank 2 is selected. If it is 11, then bank 3 is selected. The overflow flag is set by arithmetic operations when there is a carry from bit 6 but not from bit 7, or a carry from bit 7 but not from bit 6 of register A. It is set to 1 to indicate that the result of signed arithmetic is erroneous or out of range. The program status word, PSW, bit D1 is a user-defined flag, PSW.1, for general-purpose operations. The PSW bit D0 is the parity flag, PSW.0, which is set when register A, the accumulator, contains an odd number of ones after an operation, otherwise, it is cleared. Accumulator or register A or ACC or simply A is mostly widely used register of the microcontroller. Results of most of the arithmetic and logical operations are available in this register. It is also a special function register, SFR, and it is both bit and byte addressable. E0H is the direct address of accumulator, and it is used to access all 8 bits of this register at a time. Operations are also possible with single bit of this SRF, and each one of all 8 bits has its individual bit address. Register A cannot be addressed indirectly. Bit 0, LSB of any bit addressable SFR is same as its byte address or vice versa. Register B is very much needed during multiply, MUL, and divide, DIV, instructions. MCS 51 has single byte instruction for unsigned 8-bit integer multiplication and division. One of the two operands of these instructions must be in register B. The other operand must be in the accumulator. Register B is also bit as well as byte addressable. Its direct address is F0H. When not used for multiplication, and division, it can then be used for general purpose. Register B cannot be addressed indirectly. Stack pointer, SP, is direct addressable, and its direct address is 81H, and it also to note that it is not bit addressable. It points to that address of the system stack where the last storage operation has taken place. To place a byte on the stack top, SP must first be incremented by 1 and then the storage command might be implemented. After initial reset, the SP is initialized as 07H so that the stack may grow from 08H onwards. System stack cannot be accommodated in the outside memory. The PCON, Power Mode Control, register is used to select power-saving modes of operation, such as power down and idle modes. It also includes a bit to double the baud rate for the serial port and has two general-purpose user flags. Setting bit 0 of the PCON SFR puts the microcontroller in idle mode, while setting bit 1 moves the processor to power down mode. The direct address of the PCON SFR is 87H and it is not bit addressable. The GF1 and GF2 bits are general-purpose flags for user-defined functions. The PD bit, when set to 1, activates power down mode. The IDL bit, when set to 1, enters idle mode. In conclusion, we revisited the structure of data memory in the MCS 51 and MCS 52 microcontrollers, including the names, locations, addresses, reset values, and functions of all special function registers. We covered the details of the program status word, accumulator, register B, and stack pointer, as well as the selection of register banks using the PSW. Additionally, we explored the bit addressable area and the power management features. Thank you for watching. If you enjoyed this video, please consider subscribing to our YouTube channel, iNet Tech Talk, for free. Stay tuned for more engaging and informative technical videos. Don't forget to hit the bell icon so you never miss an update. See you in the next video.